Good morning all of you. In the last class we have discussed about the different methods of disinfection, and today we will discuss about the chlorination. So chlorine in its various form is universally used for disinfecting public water supplies. It is cheap, reliable, easy to handle and easily measurable, and is capable of providing residual disinfecting effect. Therefore, it will provide complete protection against future recontamination of water in the distribution system. But the only disadvantage is that when it is used in greater amount, it will impart bitter and bad taste to water. Next, we will discuss about the disinfecting action of chlorine. So, when chlorine is added to water, it will form hypochlorous acid or hypochlorite ions, so which have an immediate effect on most forms of microscopic organisms. So this is the reaction. So this hypochlorous acid formed is very unstable. See here, this is very unstable and it may break into hydrogen ion and hypochlorite ions, that is OCl minus. So this reaction is reversible and depends upon the pH value of water. So the dissociation of hypochlorous acid, that is HOCl, into ions is more effective at high pH values and vice versa. Thus, when the pH value is greater than 10, only OCl minus ions are found. And while in pH value of less than 7 and more than 5, HOCl will generally exist without dissociating into OCl ions. That means while the pH value is less than 7 and more than 5, this HOCl will remain in this condition and it will not dissociate into OCl minus ion. And in the pH range of below 5, the chlorine does not react and remains as elemental chlorine. Okay, that means this equation, that means this chlorine will react only when the pH is greater than 5, and when the pH value is less than 5, it will remain in this portion, that in this state, that is elemental chlorine. Okay, so out of all these forms of free available chlorine, the hypochlorous acid, that is HOCl, is very much effective. Therefore, the pH value of water during chlorination is generally maintained slightly less than 7, so as to prevent the formation of OCl minus ion. So next we will discuss about various forms in which chlorine can be applied. So chlorine is generally applied in different forms, such as free chlorine, in the or as combined chlorine. So as free chlorine, it is available in form of liquid chlorine or chlorine gas, and as combined chlorine, it is available in the form of hypochlorites or bleaching powder, chlorine tablet, chloramines and chlorine dioxide. So first we will discuss about the liquid chlorine or chlorine gas. So this molecular chlorine can be, that is Cl2, can be carried and applied to water either in the liquid form or in gaseous form. And the liquid form is generally preferred and exclusively used in these days. Chlorine in its gaseous form is a greenish yellow gas and it is heavier than air. So gaseous form of chlorine gets converted into liquid form when subjected to a pressure of about 700 kilonewton per square meter. And the liquid chlorine which is formed is heavier than water and is generally available in steel cylinders weighing from 50 to 100 kg under a pressure of 700 to 1000 kilonewton per square meter. So when it is required, the pressure is released and the liquid chlorine gets converted into gas which escape out of the cylinder and gets dissolved in water to make a solution in the chlorinator, and then it is fed to the water to be treated. So this chlorine gas is neither burn nor explode and can therefore be safely stored in steel cylinder either in the gaseous form or in a liquid form. So this chlorine is applied to the water through an instrument called chlorinator. Okay. So this is the instrument. So solution filled chlorinators which use liquid chlorine are used in these days. So an ordinary solution filled chlorinator takes the liquid chlorine from the container, measure it and mixes it with a small amount of water to form a strong chlorine solution. Then this solution is fed into the distribution main by means of a water injector. Okay. The chlorine should be applied at such a point in the water system that good mixing of the chlorine with water can be ensured and at least 20 to 30 minutes of contact period is available between the point of chlorine mixing and the point where the first consumer is served. So this is all about the free chlorine as chlorine liquid or gas. Next we will discuss about the use of hypochlorite and bleaching powder. The calcium and sodium hypochlorites may be used for chlorinating small public supplies. So this calcium and sodium hypochlorite can be used for chlorinating water supply. So when such a hypochlorite is dissolved in water, so it will dissociates and form hypochlorite ions. So when calcium hypochlorite dissociates, it will form hypochlorite ions. So this is the calcium ion and this one is the hypochlorite ion. So hypochlorite ion then further combine with the hydrogen ion that is present in water to form hypochlorous acid, and this process is known as hypochlorination. Okay. This hypochlorite ion as well as hypochlorous acid both are effective disinfectant of water. And another chlorine compound is used for disinfecting water, that is bleaching powder, whose molecular formula is CaOCl2. So this compound is a white amorphous powder with a pungent smell of chlorine, and it contains about 30% of available chlorine. But it is an unstable compound, and on exposure to air, light or moisture, it will rapidly loses its chlorine content. But hypochlorite and bleaching powder are generally not used in modern days for treating public water supplies, mainly because they will raise the pH value of water due to the lime content, and they contain very low amount of chlorine. So but they may be adapted for treating small supplies such as swimming pools, well, tube wells, storage reservoirs, etc. And also they can be used as an emergency disinfectant. Then next we will discuss about chlorine tablets. So chlorine tablets may also be used to disinfect small quantities of water, but these are very costly and they are available in the market as halogen tablets. So these tablets are a single tablet of 0.5 gram is sufficient to disinfect 20 liters of water. So these tablets can be used for treating overhead water storage tank or for treating groundwater supplies. And also this can be used for retreating the public supplies at the customer's end or consumer's end during waterborne epidemics. Next one is use of chloramines. Chloramines are the disinfectant compound which are formed by the reaction between ammonia and chlorine. So these compounds are quite stable and can remain in water as residual for a sufficient time. Hence, they can provide a greater safeguard against future pollution. But they are comparatively weaker disinfectant as compared to free chlorine. So the advantages of chloramines are they do not cause bad taste and odors, and they are very useful when phenols are present in water, because reaction of phenols, if phenols are present in water, then this can be proved to be a good disinfectant, because when phenols are present in water, if chlorine is applied alone, it will result in the creation of disagreeable taste, but no such taste will be developed when it is react with chloramines. So for producing them, ammonia is added to the filtered water before adding chlorine. Under normal condition, the amount of ammonia used generally varies from 1/3 to 1/4 of the amount of chlorine. The ammonia should be properly applied and mixed with water about 20 minutes to first the ammonia is properly applied and mixed with water about 20 minutes to 1 to 2 hours earlier than applying chlorine, 20 to 1 hour. So this contact period of ammonia is being kept higher when phenols are present in water. The ammonia is applied by a separate machine called ammoniator, just like that of a chlorinator. The chlorine is applied by chlorinator and ammonia is applied by a separate machine known as ammoniator. So separate machines for feeding ammonia and chlorine are required, because the two chemicals react differently with materials in the feeder. Since chloramines are weaker disinfectant, either higher dose or a longer contact period must be used in order to achieve the result. So next we will discuss about the use of chlorine dioxide gas. the chlorine dioxide gas, that is ClO2, is a very effective and powerful disinfectant. It is produced by passing chlorine gas through sodium chloride. So this chlorine dioxide gas is, so it will form chlorine dioxide gas. So this is very, this chlorine dioxide gas is costly and very unstable and has to be used immediately after its production. So it is generally not used for treating ordinary public supplies. This is not used for ordinary public supplies. It may be used for treating waters containing larger amount of organic impurities, and it is used for treating water containing phenolic compounds. So the normal dose of chlorine dioxide usually ranges between 0.5 to 1.5 milligram per liter. So this is all about different forms of chlorine, and in the next class we will discuss about types of chlorination. Thank you.